Hi, and welcome to our Software Automation Tools and Techniques Software Automation Tools and Techniques presentation for the Software Engineering module. The question we're going to be asking throughout this presentation and answering is, how can automated tools be used to ensure better quality software production? The 5 main areas of software automation tools and techniques we are going to be looking at are code generators, bug management, source code management systems, profilers, and testing tools.
Code generators. These are the topics I will be covering. Code templates, code generators, code autocompletion, and code refactoring. Firstly, code templates. This is a default template for a basic application structure, meaning you can create a specific template for a class, say for instance an author's name. So instead of every single time you create a new class, you have to put author's name. You use once, write once, and use multiple times. It reduces the need for rewriting the same code. You could create a class that has certain properties. You could write once, you set a template, and use multiple times. Code generator tools. These generate code for the UML diagram. So what you could do is draw your UML diagram with your classes, attributes, and operations, and the UML tool will generate the code for these classes. So it will make a class of a class name and put attributes and operations. Generate code from a WYSIWYG for GUI, which is just as described above. Just need to write the program logic. All you have to do is continue the implementation of these functions that you might have.
Right, I'm now going to go through the process of generating code by using UML tool. The program I'm using here is called Argo UML. It's a freeware available from the download site. As you can see, I've created an account class already, and I'm just going to create a simple class to show how the code is generated. As you can see, the interface is really easy to use. Just going to name my class. And it's really easy to add some attributes in there as well. As you can see, the types have been put in there automatically for me. This class is a subclass of account. I can show that easily here by using one of the tools. There you go, it shows a generalization. After that, it's really easy. All I have to do is generate all classes, select the programming language that I want to use, and generate the code. The code will be outputted, as you can see here, and we'll create the code.
Code autocompletion. This speeds up typing, reduces the amount of typos you might have. Say for instance, if you have an if construct, it will create an automatic if construct, and all you've got to do is fill in, especially for for loop. It helps memory. Well, it helps me and it doesn't. It helps memory in one respect, as if you forgot a certain construct, it will fill in that construct, but filling in the construct doesn't make you physically redo the stuff, so it makes you memory, but it's fine like that. Code refactoring makes changes to the code for you. Say for instance, if you have a class and you've implemented it lots of times in your code, and you want to rename the class, you would have to rename every single instance of that class. With this, you can rename the class once and it will change it dynamically. Allows changes in the sign during implementation, so this can be done during your codes.
Okay, using the NetBeans integrated development environment, I'm going to demonstrate a few of the topics from the last section of the presentation, code generation. I'm going to demonstrate code templates, code autocompletion/suggestion, and code refactoring. So I'm going to start by creating a new project in NetBeans. Create a Java application. I'm going to call it project. Okay, as you can see, it's created it with the template for a main class here. You can edit that template by going to Tools, Templates, down to here, and you can open that in the editor. You can also create your own templates for anything more diverse that you wish to create. Okay, we're going to start by adding a new class to this project. Java class, I'm going to call it presentation. Okay, we'll just give this a variable, a, and two methods. We're going to have getA, which returns a, and the setter method, setA. Okay, we'll go back into the main class, create an instance of that. Right, now as you can see, when I've chosen the myP object, which is of type presentation, it's loaded all the methods that are relevant to that class. So I can just simply go down to setA, put in 5 there, and we've used the code auto-completion / suggestion there. Now, if I wanted to rename that class, I can use the code refactoring. If I go into the presentation class itself, there, right click on it here, refactor, rename, and I can call it fish. And throughout the code, every instance of the class name has been changed to fish.
Debuggers. These are computer programs used to test and debug code. You can locate the point of a crash within an application, and you can step through to a specific breakpoint to find out where the application's crashing. Bug management. We have bug tracking systems, so you can input bugs into the system. You can track them throughout their progression through the life cycle. Known bugs can be recorded, and you can also track the current status so we know if they've been fixed, if they're currently being fixed, or if we're still investigating them. And we can also assign bugs to different personnel within a team. So if we've got a team of engineers, we can assign different bugs to different engineers so they can be fixed. Source code management. This allows multiple programmers in a team to work on the same project. It has features such as file locking, so only one developer can work on any particular file at any given time. We can merge new code together, and it has several benefits. So we can compare revisions of the software, we can restore older versions so we want to go back, and we also have profilers. This is a great way of dynamic program analysis. We can gather runtime behavior information about an application, and we can use it to optimize the software. We also have many testing tools available, such as instruction set simulators to run through an application multiple times very quickly. We have program animation. Again, we can animate certain parts of an application and step through them. And we can also benchmark our applications, so we can run the same software multiple times on different conditions and on different hardware, and we can find out how that affects performance. And finally, automated documentation. In Java, we have the JavaDoc facility, so we can automatically generate API documentation. This actually comes in the form of an HTML file, well, files to be precise, that create documentation from the source code and the comments we've put into our source code. For any questions and answers, please feel free to email us or contact us on Twitter with any questions.